Alright, so for today I was looking through the Book of Shaders book, and yeah, I found it really interesting, the Perlin Noise thing, and I was thinking of implementing that myself. And basically the idea of why would be probably being able to generate maps for a game in the future. And yeah, I think that would be useful to have like knowledge on how to do that, right? And yeah, um, this one is really cool. I'll also link it in the description because you can actually just play around with the code itself and it does change it. So yeah, let's first go a bit through, I guess, the explanation of what this stuff does, and then we can try to implement the Perlin noise as it's described here in JavaScript to generate a map of some kind, like a mini map. So yeah, basically the idea is, let's say we have an X, right, and like on the graph of numbers, and we can apply functions on it to generate some random stuff. Like you can imagine that this could be a valley and this is a hill or something, and we can play around with the amplitude and frequency, right, to make all sorts of shapes. But this one isn't really that random, right? So it's just a sine wave. And one cool thing is like the thing that we have to implement is called noise. And yeah, this case is one dimensional, so not that great for our use case. Although we can make a 2D scroller game that has this terrain, and you have to yeah, I don't really know what, like I don't really have that many ideas for what the game could be like, but I'd like to have some random features, and then we can merge them into some kind of game. So yeah, like this looks more like a terrain, right? So we can decrease the amplitude more, and or increase it and have more hills. And frequency is basically zooming in or zooming out, right? That's pretty much how it works. But again, like this looks nice, right? Like would make a nice terrain, but it's not that interesting. So I guess in this example they were showing like scrolling through the thing itself, but yeah, like to make things a bit more interesting, like to add more details, because like the main issue with this thing is that it's not detailed enough in my opinion. Like we can zoom out and this kind of looks like it increases the detail, but we also have to decrease the amplitude, and yeah, we lose the hills. Like we don't have those like huge hills on the map. So yeah, like let me just make it back to 1, right? So that would be the main issue. Like we want to have details on these hills themselves, and one way to do that would be, let's copy these bit by bit, right? Because it'd be nicer to see actually what happens. So let's imagine we don't have this stuff. It's for now. Right, so now it's still the same thing as it was before, right? It's exactly the same. But what happens if we apply noise multiple times? Well, I guess what happens, it's basically the same thing, right? So not that much changes, I would assume, if we just change the number of times we apply the noise. And yeah, well, I guess it wasn't really the best explanation of why we require those extra parameters. But I mean, let's make this one look the same as the original one. One sec, just refresh the page, it's easier. So if we have this one, right, it looks like this. And if we go down here and change the amplitude to 1.0 or 1, it's gonna be the same as the original one, right? But what would happen if we just try to apply noise multiple times? I mean, we can comment this out just to see the difference. So if we apply it twice, it just increases, right? But we would like to, on the second time we apply the noise, we want to have other frequencies and amplitudes, and we can do that by doing an update, right, on them. And I guess that's the point of lacunarity and gain. Like, gain is going to be applied on amplitude, right, and lacunarity is going to be applied on frequency. Basically, each time we apply the noise again, we just increase this thing, we increase the frequency. So like the second time we apply noise, the frequency is going to be higher, and I guess amplitude is going to be smaller. So yeah, we can try to apply it like 8 times or something. And as you can see, it has a similar shape to the original one, right? It has a similar shape, but it has more details on the hills themselves. So that's the main idea, right? And I think this one is called actually I lost the name, but it was something like fractal Brownian motion. And yeah, basically we'll try to implement noise, and then we'll try to add this extra stuff which just applies noise multiple times. So yeah, and if we do this thing in 2D, right, then we would be able to generate stuff that looks like this. And my idea would be, based on the height map, we can have different kind of terrain. So like hills, mountains, plains, like different biomes, like in Minecraft. So yeah, let's actually try to do this kind of stuff, although it's gonna be done in JavaScript, not necessarily like this. So all right, let's see. So we're gonna have like an index.js. I can copy it from the last time, from so this is gonna be like Perlin Noise, and I guess this thing was called FBM. Okay, let's call it index.js. So yeah, I mean, this is the standard template I always use for JavaScript demos. Like, we have a root div and then index.js, which is gonna basically create a canvas, right? Yeah, and do all sorts of stuff. But yeah, we actually need to implement the noise function, and for that I would use the Wikipedia version. I don't know, like, why are there two, but one of them is useless. So yeah, like this kind of stuff, right? And yeah, the implementation is not that big, although this is I think it's C. So we can just try to use it. To be honest, I would assume that this is similar to the original one, but it says that it has major differences because it's in 3D instead of 2D. So who knows? But yeah, I guess we just need an implementation and then be able to add these extra things right on top of it to implement FBM. And yeah, afterwards we'll be able to generate some kind of terrain looking stuff. So I mean for a mini map kind of game. So I guess the main function is this one, Perlin, right? And as you can also see here, it takes in an X coordinate, but in 2D it's obvious, it takes in X and Y, and in 3D is gonna take in X, Y, and Z. But that's also what we are gonna need. So let's say we do a function. I guess we can call it noise, maybe 2D, but I don't remember if in JavaScript you can have overloaded functions and just call it noise in case we want to do the 1D version. So yeah, so the first thing would be to get the grid cell coordinates, and I guess that's because reasons which I'm not sure about, because down here it just makes it back to float, but I guess it's like maybe getting like the fraction part of the numbers. Looks like something like that, right? Like it's yeah, I mean, let's just try to follow the algorithm and not really question it, because probably it's good. So we can compute let x1, and let's say x1 is gonna be floor plus 1. You see that's how it's computed. So we can use math floor x plus 1, and I guess JavaScript doesn't have types, so floor y plus 1. So this gives us these two values, and then, well, it actually also needs x0, so might as well just keep all of them. Let x1 is x0 plus 1, y0 plus 1, right? So something like this. Then we can do interpolation weights, and yeah, I guess this is a number between 0 and 1, right? Because we just do floor on the number. So like the idea would be, let's say we have a number like 3.123, and if we apply floor on it, I guess we have floor, right? It's gonna be 3, and if we subtract this, we get a number. That's interesting. We get a number between 0 and 1, and it's like a scale, right? Like a weight. So let's get that. Right. So let just want to make sure that this won't do any JavaScript issues. Y is gonna be y minus y0. And let's do it like last time when we added comments in the code. it makes it but you know, I mean, you can easily just follow the Wikipedia one and do it. So anyway, and I guess the last step, which is implementing the interpolation. I mean, we need to also implement these methods, obviously, but yeah, let's this part can just be copy pasted, you know. I guess this probably is part of the original algorithm, so no idea what it should do, right? So let's just pretend that we have this method of computing the dot product of distance and gradient vectors. Like here we pass in some x and y and another x and y. Then it does random gradient, which is a custom random function. I guess then it does this distance vector, right, between the, because here we pass in the integers, right, and the original values of x and y, but we do it like, let's say, I don't know if I can just draw it. The other way around. So would be something like, let's imagine that we have, let me just move this one, it's easier to have it on 3. So let's imagine that we have a square. I don't know how to get the square, but right, we have this kind of square, and we have a, well, let's make a grid actually. Maybe it's gonna make, but you know, I can make it a bit bigger. So let's imagine that this is the map that we have, and it's gonna be split into this kind of like columns, rows and stuff, right? Now we can finish. Okay, I mean, let's just pretend that, okay. And let's say that we have a position somewhere here in this square. Well, we are gonna, you know, floor it, right? So if we floor it, let's imagine that this is 0, 0, because you know, computers, this is width height. So if we floor this x and y, we are gonna get this corner right here, and if we add 1 to it, we are gonna get this corner, right? So basically this would be the idea here, like that's why we do this. Then sx and sy is just, I guess, the difference from here to here. Like it's this vector. Wait, let me see, which direction is it? So it's x minus x0, so it's in this direction, right? Something like that. I mean, you know, pretty ugly, but it starts from here and it goes in this direction. And then here in dot gradient, when we pass the arguments, you can see it's x0 y0, so it's something like x0 y0, and then x1 y0 and x1, so it's this point and this point, right, for the first two, and for the second one it's this point and this point, right, in here, and it also passes in the original point every time. And I guess what this thing does is computing x minus the thing. So when we do x minus the thing, it's always like this this vector, right? Kind of like this, because it's x, like this is the origin, and this, like, I guess this is the point of the vector, and this is the origin, right? That's how it works. I don't remember from math, to be honest, but yeah, like here we also do gradient, which gives us a random number, or a random vector, I guess, or something, based on sine and cosine. So yeah, I guess, you know, makes sense that Perlin noise is based on sine and cosine, because it looks very sinus cosinus. Okay, so yeah, here we just get a random direction, and I'm not sure what range these values have, but since they are sine cosine, probably it's -1 1, right? Makes sense. And yeah, I guess what happens here is we just randomize these vectors, right? So we just randomize these vectors, so they're gonna be either like smaller or in the opposite direction, right? Like it's gonna be somewhere in this range if we do this random. Or I guess, oh, it's a dot product, didn't realize that. So I mean, you know, then this doesn't matter. It's a dot product, so it's, I guess the dot product is actually the what's usually it's called the angle, right? It's for getting the angle, but you know, it doesn't really matter. So that's the first step, right? We get those vectors, and then we do dot product with, I guess, a random gradient is gonna be some kind of vector, like random in these directions, doesn't really matter, right? And we do the dot product between this vector and these random vectors. So I guess that's the point. And dot product, yeah, I think it's like cosine of the angle between them, right? Am I wrong? I think that's what it is. But you know, it's like a number, and that's how we actually get it. Then what do we do here? It's interpolate. We interpolate. So for example, as I said, the first step is the 2 from above, and the second one is the 2 from below. So we interpolate between these two numbers, right? And 0 and then 1 with sx. It's pretty interesting. So we interpolate by using this, I guess it's not that, it's actually this distance, sx, distance between this edge and the point. Which, I mean, it's a bit interesting why we chose that distance, but you know, it is what it is. And what does interpolate do? I guess just basic interpolation, you know. And yeah, here we can play around with more interpolation functions, I guess. I don't know, we'll see. I mean, it's gonna be easy to just change the interpolation function, but yeah, so it's gonna give us a number between these two values, right? Which, even these values, I think they are between -1 and 1, since we do, well, it's not really the cosine because it's not normalized, right, by the distance or whatever. I don't remember how you do that, but you know, pretty sure that the dot product is not, or is it only this? Who knows, I don't remember, but that's gonna give us like this ix0 value, right? So interpolating between this with this, and then we interpolate the ones from below. Like we do some, basically it's just doing random computations on random values that are somewhat linked to this point in the middle, right? So that's the idea. And then we just interpolate between these two values, right? And I guess the point is this value is going to be between -1 and 1, mainly because we did cosine and sine here, and this thing returns -1, 1. Then if you do the dot product, right, between some vector that is between 0 and 1, because this is going to be 0 and 1, and -1 and 1 is going to be still in -1, 1. So dot gradient is going to give us a value between -1 and 1, and interpolate, obviously it's going to keep it the same. So yeah, right? So I guess the only thing that is like copy pastable, well, I mean the entire algorithm is copy pastable, but this thing can be, let's say, changed until we like how the noise looks like. But yeah, hopefully it makes more sense now how this thing works. To be honest, it makes more sense to me. Like, I guess not necessarily more sense like why does it work, but more sense in the idea of how does it work, right? I don't know if that makes sense. Like, we know what each step does, but to be honest, I have no idea like how can you think of this, to be honest. Like, how can you come up with this algorithm? Like, surely it was just random stuff until something happened, and now it became like an algorithm. So probably that's how it works in this case. So, all right, so let's try to, actually let's define this variable. So let's do it exactly the same. So let's let this stuff, so we get those, and pretty neat that we can actually just copy paste. So no, now it's time to copy paste. So this is how noise works. All right, so the next step would be to implement dot gradient. So obviously we are gonna copy paste it, right? Well, let's not forget about the comment. Okay, so we are gonna have the integers, like the corners of the square, right, as I showed you, and the position. Here we get the gradient, which is going to be that random function, and I mean, since it's JavaScript, we can easily just, you know, compute the distance vector and then compute the dot product. All right, so I think that looks decent, right? This part. Let's now take the pseudo-random direction vector, which, yeah, let's see how this one is implemented. I'm curious, to be honest. No, this is too much. Okay, random gradient. So it takes in these two integer positions. We don't need that. Well, this is interesting. it needs size of unsigned. I mean, size of unsigned, let's see what value it has. So include stdio. I think it's, to be honest, I don't remember if it's percentage LU or something. Some stuff like that. Right, so let's see. Looks like on my system it's size 4, so probably on everything. Right, so here we compute some W. No idea what W is. Then we have rotation width. Then we compute some A's and B's with random values. I'm curious what this permutation is for. Because I don't see here anything about permutation, or maybe I'm blind. So here we get the rotation width. Then we should let it let A and B, and here, you know, looks like it's updating A and B with some crap, and here we get a random value. So this is pi. No, I'll still say that maybe this is how it was implemented originally, so I'm not gonna use constant pi here, I'm just gonna leave it. Oh, and this one is interesting, right, because it's, why is it interesting? Because it makes a difference. Let's say we print a D, right, we do this thing. If we run this, we get -1, but if it's unsigned, let me see what does it. It's still -1, but if we show it as U, pretty interesting. I'm pretty sure it should have different values. And I mean, this is kind of lame. No, we can take this thing, see what value it has in C, and probably just use it, right? So it's minus something. Okay, I'm pretty sure it has to be unsigned. Then, so it should be this kind of value. Yeah, I mean, you know, I'm not sure what would happen in JavaScript if we do this thing. So let's see what happens if we just run this entire thing without a U here. Funny, we get 0. So this would be -1, obviously, but what if we shift it? See, like, it has no idea how to do shift operations in JavaScript. That kind of sucks. I guess the only good part about this one right here is that A is gonna be positive, so this shouldn't be an issue. right? So that shouldn't be an issue, but this one seems like it is, right? So then what I would do here is instead just use the number, because I mean, JavaScript being JavaScript, we can even just keep a comment here with the original thing. Maybe, you know, if we implement it in another language in the future, just to, you know, because I'm not gonna do a game in JavaScript, that's crazy to be honest. Alright, so in this case we can just have this class of class vector2, and it's gonna be x. I don't even know if that's constructor xy. Okay, so you know, we can just return new vector2, and we pass in cos random, sine random. Maybe one thing that we can do is show random, and let's say we do like for let I is equal to 0, like we try a bit this function just to see that the replacement that I did is actually fine and it's not like some crap. Okay, so random gradient. Let's do a bit of a benchmark. So just node the index. Oh, it's a math cos. Math sign. Okay. So we get crap. It doesn't look good. Yeah, like this says that it should keep the value between 0 and 2 pi, but it looks like it doesn't really do that. Well, I guess I'm curious, what's the value of a? Should be like in the same whoa, that's insane. You know what, I'm really not sure how did we get negative values. Like that doesn't make any sense to get negative values, am I right? That's insane. Okay, let's see, like what happens if we have, I don't know, like 2, 6, like -5. Yeah, still the order of operations should be fine. What if we, I don't know, or it with 2 shifted by 1? Yeah, I mean, it still looks good, order of operations. So I'm really curious, how did we get negative numbers? So let's say if a is more than 0, let's show ix and iy. And let's also return or something. Or I guess exit, but I don't know how to exit. You know what, I mean, we'll figure it out if... Okay, so it's like for this value, right? You can manually do each computation, see what the result was. Or we can even like console log a b, see where the oopsie doopsie happened. So it's like, what the fuck is this? Oh yeah. So this is the a value, a and b at this point. So b looks negative to me. Why the fuck is that? In a way that in JavaScript numbers are actually capped, or are they? I mean, this is unsigned on 32 bits, so that's insane how we overflow that. So I mean, this doesn't overflow because it's a, it gives us like a humongous value. Let's see the value. Like clearly it's larger than, I mean, it should be this one multiplied with 35, right? Like that's yeah, 0.5 in the end, yeah. And then for b, which is really strange, it's that value shifted by 16, so it's this value. Actually, let's just take this. Can I clear? This value shifted by 16, so it should just cut from it. Am I right? It's like shifting to the left, it's just like dividing by 2, if I remember correctly. And the other one is, see, like this is a bit strange. W, I mean, makes sense, you know. And this one is like multiplying by okay. Well, that sucks. Do we have a big int? Big int by 16. But how can we... Well, what if this makes sense? Okay, so let's just convert to begins by putting an n at the end. Right. Whoa. Let's just try it. Let's see what happens. So if I try to run it, it's not gonna like something. I wonder what. Oh, so I have to say new begin. Let's just keep them as integers up until this point, right? Oh, it's a thing. Sure, fair enough, whatever. 0, are you fucking... Oh, yeah, sure, it's gonna be 0 because it's 0, 0. But what if we try... Bruh, our old friend 35. What if we try these numbers? No, let's just plug them in. Why not? Like this, debugging. Sure. What a huge number. That's bad. That's clearly not gonna be in 0 to pi, if you are gonna ask me. But I mean, you know, it just looks like that's the thing. But why is it so big? It's interesting. Like, this makes sense, sure. And then how about this? So we take this big int shifted by 16n. Like, this is dividing. No, this is, yeah, this is the dividing. This is multiplication. And then we OR it like this. So yeah, that's what I would expect, and that's exactly what we got. Not really, because we have to XOR it with B, and I guess B is this number. So let's see what happens if we also XOR. But see, we get something different. We get something a bit different. It ends in 772. Okay, let's try to use parentheses. Who knows what the fuck this shit actually does. Right, let's see, maybe JavaScript has different order of operations. It actually does. What the fuck? No, I'm not even surprised that JavaScript... I mean, you know, this was... I was pretty sure this was gonna be the most painful function to implement, because JavaScript is not really made for this, but... Okay, and what the hell is the second one? So, I mean, this one looks fine, to be honest. Even though it's a humongous number, it looks like that's how it should look like, for some reason. But after that, I mean, we multiply the number again. Holy shit, oh, you know what? We don't take into account the thing in C. We have modulo, right? We have the modulo stuff. So I guess we don't really care about modulo until the end, like here. How can we generate a quick and easy modulo? So it would be 2 to the power of what, 32, like w minus 1, right? So it's, let's say let m is gonna be 1n shifted by w and everything minus 1, right? This is the final boss. So then we can say a is equal to a modulo m. So now if we run it, we should get a smaller number, and we don't care of this being huge, I think. Or do we? should we care about that? Let's actually do care about it. So here we modulo by m, because it's just adding modulo by m everywhere. So you know what, like, I'm not even joking, I'm just adding modulo everywhere. And I'm using parentheses obviously because we never know what the fuck JavaScript does. So a times modulo m. Alright, so let's see if it's the same value, 288 something something, and it's not, so it actually mattered. Which is always fun. Okay, so let's go back to IJ. Alright, so now the question is big float. Obviously we don't have a big float. What if I say number A? Is A gonna suck or is it gonna be fine? Wait, what? The fuck? Oh, it's a number with capital. I mean, it looks alright. Maybe it's a bit too big, to be honest. And let's console log the random value. So yeah, it looks like it's between 0 and 2 pi. Okay, perfect. So we actually managed to get this shit done. I mean, it's really painful, but it actually worked. Like, that's the downsides of using JavaScript. Even though it's easy to add the graphics, it fucking sucks. Okay, I mean, it sucks at math, so I mean, it's pretty funny that it sucks. It's like, it's so perfect, like, it's, the irony is so good that it just sucks at math. Okay, function interpolate. Okay, let me just also copy, I mean, I'm even copy pasting, so I shouldn't complain about JavaScript. Okay, anyway, so probably this should work, right? So let's have a for loop. Like 0 to 100. I know I just deleted the old one, but and let's do something like let n is equal to noise, and let's do I divided by 10, j divided by 10. Let's see if the noise is right. I mean, it looks good to me, to be honest. Yeah, looks good to me. Okay, so I guess that's all for Perlin Noise. Let's try to get FBM now done. I guess maybe the next thing would be to actually display the Perlin Noise. That would be more fun to have. So let me just go into the arcade demo and you know, let's just copy paste from yesterday's thing, right? No, like the worst part about Vim is actually copy pasting stuff. I'll be honest about that. So let's just go GitHub. Like I need a better key binding for copy pasting into the main buffer, you know, better copy paste. But I have no idea what would be that thing. Okay, so let's have again background. So this would be like negative color, so when the noise is negative, or I guess mean color and max color, something like that. So like what I need is creating the canvas. I never remember how to do this shit, so that's good. And then we just have to draw it. So does it make sense to have draw frame? Not even sure, because it's gonna be just shloop, you know what I mean. So obviously we are gonna go from 0 to this and this, and then maybe we are gonna have a const step, which is gonna be like 0.1. So you know, we can multiply our x and y with this step. Basically it's more like the frequency, but it's gonna be like the base frequency or something like that. Yeah, like a kind of zoom, but hard-coded. It's not gonna be part of the parameters. Okay, so I mean, let's try to see how we can actually draw pixels on this crap. So for I'm doing the for loop the third time. Whatever. X is smaller than width. X plus plus. Then we do the same thing for y. Smaller than height. Alright, so we have x and y where to draw, and let, I guess, nx is gonna be x times step, is gonna be y times step. So nx and ny is gonna be used for Perlin noise, and x and y is gonna be used for drawing. So let's get value. Let value is gonna be noise nx ny, right? Oh, I need another function, color interpolate. I mean, I have an interpolate, but I don't like it, so oh, Java, you know what, let's just JavaScript interpolate colors. Jesus, is it really that difficult? You know what, let's just copy paste this crap. So I guess this is in RGB style, split by comma. Jesus Christ. Well, my color is like this, so oh, well, this fucking sucks. Holy shit. Yikes. Yeah, I mean, hate this one. So okay, let's do it by ourselves. So it's a good function to have, like interpolate colors. We are gonna have color 1, color 2, and I guess F from fraction. So function get RGB color, and what this thing is gonna do, we have to slice. So color dot slice. Okay, slice. What argument does it take? What JavaScript string slice. Okay, it takes in. Okay, the start and end. Oh, okay, perfect. So 1, 2, right? Or is it like? Bruh, where's the definition? Okay, start index and end index. Perfect. So start index is 1, end index should be 3. So this is number, right? G and B. So then 3, 5, 5, 7. Okay, let's pretend that. So color 1 is gonna be get RGB. Get RGB of the second one, right? Makes sense. And we just need to return function put RGB. I don't know what to name this shit. So ooh, format printing. Oh my god. So how can we JavaScript format string with leading 0, right? That's, oh no, oh, bad left pad. Or no, that's to be honest, npm install left pad. No, what? I'm just kidding. What the fuck is this? Okay. Oh, I see. Pad start. Okay, so I mean, you know, the easiest way to do it is, bro, what the fuck is that? Okay, so let's convert it to a string, right? And we need to pad start it with 2 zeros. The brain rot of JavaScript starts to set in. RG and B. Okay, I mean probably. Oh, almost first try. Okay, so we have color 1, color 2. Then we have let color 1. Yo, how can we do that? So we take f of the red value. Oh, you know what? I mean, we have the interpolation. Function linear interpolate xyf, right? like let's do the math here. So we have x times f plus y times 1 minus f. So we are gonna assume that f is between 0 and 1. So and we can just then put RGB of R is gonna be linear interpolate. Can I enable ChatGPT just for this? Okay, should probably work. RG and B, FR, RB. Okay, looks good to me. I mean, you know what, I would like to have them a bit formatted, because I cannot read anything, like the font is too big, I think. Anyway, oh, I have another idea. Usually JavaScript makes sense to do this. Okay, I think you know, interpolate colors should probably work, hopefully. So now we can get back to this. So value is actually between -1 and 1. So as it says on Wikipedia, we can multiply by 0.5 and add 0.5 to this thing. So let's go somewhere here. Value is equal to value times 0.5 plus 0.5. Let color is equal to interpolate colors. And we get a color. And now I want to draw some stuff. So let's where's the context? Here is the context. Let's get the context and JavaScript context draw pixel. That would be cool. Draw pixel. Oh shit. Well, I mean, GG. Actually, probably makes sense to do this. Right. Fill rect, we give it XY with height. Why not? Why not? So, oh, and now we can actually Python this. Localhost 8080. Jesus, why is it all black? I mean, it's not even gray, it's just black. What? Let's console log the color. Yeah, it doesn't feel that. Oh no, hopefully just the browser crashed, but okay, I mean, looks like it's not a good idea to do what this guy did. So probably a better idea is to create an image and yeah, let's try to context put image, right? That's what we want. Put image data. Put image data, and we put the image data at the end. So ctx put image data. Probably 0, 0, right? It's like the beginning. And we want to build this image data. So let's see how we can build the image data. Let image data. I think it comes from, well, it's created using the constructor. We can maybe get image data from the canvas, right? So is equal to ctx.get image data, and this shit looks like we give it 0, 0, canvas width and canvas height. And that's how it looks like. So sx and sy with height. I'm sure looks good to me. And instead of filling a rect, single rect, let's see what happens if we go back to localhost 8080. It still just fucking died. It's still slow AF. It's none. Bro, you are bugging. Jesus Christ, it's too big, to be honest. Let's make it a bit smaller. 800 by 600. But oh my god, my interpolation color function sucks. I guess I want to go ChatGPT, but okay, let me just make sure I just reopen the browser just in case, and also the recording just in case. So JavaScript, make me a function that interpolates two colors, RGB, with a 0, 1 float. It's substring, not slice. Interesting. I mean, I was close, but at the same time, this, maybe it's actually gonna happen. Maybe we are gonna get replaced by AI. What the fuck? Yeah, you know what? Like, let's pretend this is what we actually want. Let's see, for example, what does it think about my colors. Max color, and let's say ratio is 0.5. And let me just remove the rest, just so we don't crash for some reason. So yeah, I mean, it looks like it gets some colors, so hopefully let's see. And nothing happens really. Whoa, we got some weird colors. So it actually ran, but I actually forgot to set the image dot data, and this is gonna be interesting. How can we actually set the data. So I can see that data. I mean, obviously, but no, I just want to modify the data, which looks like it's RGBA order. So holy shit. What would be the most efficient way to do that? Like maybe one way is to get these values, right? That's the first step probably. From the color itself, we parse the integers, and we have to set like the index. Let index should be y times width plus x, and we have to do something with 4 because we have 4 things. I think it's multiplied by 4 if I'm not mistaken. So it says RGBA, right? So index plus 0 is gonna be R. Let me just, oh, another idea is we don't need that. Alright, so we have then, wait, is it 3, 5, yeah. 3, 5 and 5, 7. And let's hopefully see the noise. But yeah, it's interesting. It's pretty slow, to be honest. Oh, and there's nothing. There's some stuff, but there's nothing on the canvas. Let's make it a lot smaller, like I'm saying sub 100. Yeah, this is interesting. Mainly because the fuck? Like maybe I have to draw something first. Yeah, I mean, it looks good to me, like the color. But maybe I have to draw something first on the ctx dot clear rect canvas width canvas width, which is canvas height. Nope. Oh, I'm also doing that. You know, let's fill it. Let's fill the thing. So context dot style is gonna be mean color. Let's see if it's gonna. Oh, and now it worked, obviously. Interesting. There is some stuff going. I'd like to make it a bit bigger though, to see some stuff. Whoa, Oh, it looks like shit. I'll be honest about that. Maybe it's because of how we do this stuff. Maybe I did something wrong there. I think it's x times... Wait, no. It's x. Okay, let's think about it. How do we index into an image which is one-dimensional? Row from top left pixel to bottom right. So row by row. Okay. So it's like this, from left to right, each row. Okay, so y, let's say x is our width. So x is the column number. So it's fine to say, no, actually let's change this to be like row up to height. Right, makes more sense to me to use row and column, otherwise it gets really confusing. And then we have column which goes up to width, and then column. So here we have row and column. So actually x is the n row and column. Usually I guess you put n column and n row, but it doesn't matter for noise. So then we interpolate that color, sure. And here we need to say something like row times width, right? Plus column, and everything has to be multiplied by 4. Am I right? It's the same shit. Oh, do I have to... RGB. I mean, it's pretty strange, not gonna lie. So this would put only mean color. Let's try to do something like if column is greater than row, we continue. Let's try to do it like only a triangle. Oops. And here let's put max color. So it should be like a triangle, right? Oh, okay, then it should be fine, right? So column is greater than row. I guess it means that we put the colors correctly. And if I do the reverse, it should be on the other side, right? Yeah. Let me just double check. So row, let's say both of them are 0, and row increases. Yeah, it actually makes sense. So it should be fine. It means that the mistake is somewhere else, because this doesn't really look that random, to be honest. Or I guess it looks like shit rather than random. But maybe that's just how it looks. I have no idea. It has these weird lines, which I will assume that they are because of this stuff. But I don't know what, let's let's just try to add the thing from here. Let's just see what happens if we just, you know, go ahead and try to make it more interesting, at least, you know. So let octaves, I guess the properties should be outside, right? Let's put them here. And these are the initial values which are gonna change. Right. So FBM, or what was it? FBM, yeah. So let's have a function noise FBM, and this should probably take in X, Y, and let's say options, right? And it should do this stuff. So options at octaves, options at and then let amplitude. Let's try this. Frequency. Okay, let's move it closer to the noise function, just to have it there. Okay. So I guess let's just change this one. Let value is equal to noise FBM, and then for options we are gonna have frequency is gonna be frequency, right? Then amplitude is amplitude, gain is the gain value, linearity is gonna be, and I think there was one more or something, right? The octaves, yeah, the most important one. Let's see what happens with this one. So now we can increase the number of octaves to 4. So let's see. Huh. Really cool. So line 33, there's a problem. The fuck? Oh, I see. So it's interesting. That's an interesting. Oh no. I was just bugging. Oh, and yeah, we have to do probably value is equal to 0, and then value plus equal, and also return value. Right. Probably. I mean, it looks more fine-grained, but it still has those weird lines. Yeah, something looks off with the randomness like I would rather just have a real random, right? Although the main idea of this thing is that you can use a seed to always have the same random world, right? Like probably that's how Minecraft does it, like in a way. Or I guess even I would say it doesn't make sense. So let's try it. Let's try to do a real random. I don't know, the main idea was I don't know. Let's try it. Let's do random. Where's the oh, math random? Okay. So it's okay. This should give us a number between 0 and 2 pi. So yeah, like if we randomize it like this, it looks better. So it's a problem with the random function, right? And I mean it's because of JavaScript. So what can we do about that? Let's try more octaves, like 8. It looks interesting. Maybe decreasing the maybe like decreasing the frequency. I'd like to see more like chunks. So maybe no chunks. That would be cool. Maybe amplitude. Not sure what should be changed to get like bigger chunks of the same color. Because my idea is not necessarily to have interpolate colors, but let's say function map colors, right? And this one is gonna be something like, is gonna take in a value, and if no, let me just use Copilot for this one. Let's see if it gets it. If value is, I guess, smaller than 0.25, let's use green, some kind of green, I would say. Alright, so actually I just use the noise function, right? I added some sliders so we can edit easily the values, and yeah, I was just adding this map colors function, so when it's lower than 25 it's gonna be blue, like it's gonna be water. If it's between 25 and 50% it's gonna be green, like plains. Then we're gonna have some brown color for like the mountains, and yeah, if it's above 75% it's gonna be white, like snow tops of mountains, right? So yeah, that's how it looks like. And actually the random function looks decent for some reason. Like I changed it back to use the normal random. Yeah, I'm not sure why it wasn't looking that good in the beginning. I guess more octaves makes it look better. And yeah, here you can see that initial amplitude is something like how extreme the terrain is. So if it has a really small amplitude, it's gonna be just plains and mountains, but if you increase it, it's gonna add water, and like it's gonna make it more with a lot of steeps and valleys, I guess, like a a lot of peaks, and yeah, frequency is just zooming in and zooming out. So see, if we have a really small frequency, it's really zoomed in, but if we increase the frequency, it starts to zoom out. And I think we can see that better if we keep, I don't know, the frequency at 1 or something like 0.5 and actually increase lacunarity. So right, for yeah, somehow it should be like the zoom level, and gain is gonna be, it's gonna amplify the amplitude. So if you increase it, it's gonna become more extreme basically, and if we decrease it, it's gonna be more like smoother, let's say. So yeah, and I also have another, I added just some simple logic of moving the map. So if we drag the screen, it should move it, right? But yeah, the issue is that it's not really that efficient, right? Because it has to compute each point each time we move and stuff like that. But yeah, like I mean, you know, it doesn't really look perfect, probably because of JavaScript issues with math. But yeah, I think it's still a good demo to keep in mind that this is how we can do terrain using noise. So yeah, basically that's I think it's decent. I think I'm satisfied with the results like this. Now maybe if we use this in a game engine, it would look better, but yeah, still okay. If we increase the frequency, it's gonna have more stuff, basically more details, and low frequency really, yeah, like it has these weird lines which I'm not sure about, like they don't really look that random. So maybe this makes it a bit more random, but yeah. And the number of octaves, yeah, like see, it has this weird thing. Anyway, we'll see. But like this would be, you know, adding some kind of terrain in a game, so we can procedurally generate terrain. But we'll see. Like, no, I was thinking of some kind of I don't know, maybe like multiplayer kind of game with random terrain, maybe combine like a tower defense. I've seen that like the current meta is kind of tower defense games. Could be interesting, I guess. I don't know, like maybe a battle royale game kind of stuff. Random terrain, yeah, and if we can include that you know, procedural animations and stuff, that would be cool. But yeah, we'll have to experiment more, like and figure out what a interesting game would be. But yeah, I mean, at some point we have to start it, because you know, it's better to start it and fail, like not figure out what to do with it and then start again a new one, than it is to just do random features, I guess. So yeah, I guess that's all for today. So we'll see in the next one.